When we imagine the solar system, we tend to have this concept of a flat disk with lots of rings indicating the orbital motion of the planets. Given that we've learnt this since we were little, we kind of take it for granted that all the planets are on the same orbital plane. Not only that, but they all orbit the Sun in the same direction. But have you considered why? Is it a massive coincidence? Or did something happen to make it this way? And if there was a process, do we have evidence of it elsewhere? As you can probably guess, it was not a massive coincidence. Because not only do we observe planets orbiting the Sun along a plane, regular moons do too. All the gas giants have regular moons that also orbit along the planet's plane, and in the same direction too. Saturn's rings orbit Saturn along the same plane as Saturn's regular moons, in beautiful clockwork fashion. So we can see that there are plenty of examples, but how and why did this all happen? Let's go back billions of years ago to before the solar system was formed. Deep in the heart of an H2 nebula, or a stellar nursery, gas and dust were suspended in place, each particle resisting the other's gravitational pull with an internal repelling pressure. Until one day, an outside push of energy, like a supernova shockwave, jolted the gas and dust inside the nebula, disrupting the inward pressure, causing the particles to collide and clump together. Soon these clumps would attach to other clumps, their mass and gravity increasing with every particle becoming attached. Within a few thousand years, impacts from the infalling material began to get more energetic, causing the object in the center to heat up. More material from the nebula cloud was sucked into the object as its mass and gravity increased, forming what is known as a protostar, or a very young star that hasn't started nuclear fusion in its core yet. At first, the infalling material around the protostar would have been pulled in from all directions, causing a very chaotic environment around the protostar. Collisions between the particles would have happened on a regular basis, and through doing so, their angular momentum would have been cancelled out. However, these infalling particles would not have approached uniformly, as the collapsing nebula cloud has a total angular momentum. So what ends up happening is that while particles approach from all directions, most of their momentum would have been cancelled out by particles going in other directions, until all you are left with is the direction most particles were going. The best visualization I can give you to help you wrap your head around this concept is this. This is a great video from Dan Burns, who uses a sheet of lycra to represent space-time. The ball in the middle, with its large mass, is warping space-time and creating gravity, which is just like what gravity does in three-dimensional space in the universe. Dan throws balls in both directions around the central object, and the balls orbit until they collide with another ball going the opposite direction, cancelling their momentum out. And what you are left with are just the balls that didn't collide and are all going in the same direction. Now, friction from the lycra wouldn't happen in space, so you can imagine particles continuing to orbit, unlike the balls that slow down eventually on the lycra. Also, this is kind of a two-dimensional representation of what happens on a three-dimensional plane in a four-dimensional universe, so you'll need to imagine these particles going along another axis too. Instead of just the two directions these particles approach from, around a protostar, they will be approaching from all directions, colliding and cancelling each other out until only the predominant direction remains, creating a protoplanetary disk. As material falls into the protostar, the angle of the impacts cause the protostar to begin to rotate in the same direction the disk is spinning. As less matter falls towards the protostar and instead begins to stay in orbit around it, material begins to clump again. If enough material clumps into one, you may end up with another star, making it a binary or even a multi-star system. Otherwise, these clumps will eventually coalesce into planets. Around these planets, a similar disk to protoplanetary disks form, again causing the planet to rotate in the same direction as the disk, and the material in the disk eventually forming moons. This clumping of material can be observed even today, with the planet that has a mighty disk of its own, Saturn. Cassini, during its mission, was able to spot tiny moonlets forming within Saturn's rings as material clumps together from various gravitational interactions. Some of these moonlets fell apart soon after, as I'm sure also happened in our early solar system. But some lasted until the end of Cassini's mission, and perhaps they will eventually form very tiny moons one day, like some of the other shepherd moons that have carved paths in the rings themselves. Now, the orbital plane of the solar system isn't perfectly flat. Some planets have variations of a few degrees, but it definitely is a pattern. It's almost beautiful how in nature you can have something so chaotic that will eventually form something rather calm and orderly. As material in the solar system like asteroids and comets continue to find homes on the planets by impacting them, less and less collisions will happen. We can already see a vast reduction in the amount of collisions that have taken place by measuring the age of craters on exposed celestial objects like the Moon and others. From these clues, we can see that all the planets were heavily bombarded from asteroids and planetesimals during this chaotic beginning, the amount of collisions gradually reducing as more material got in order, until what we see is the solar system we have today. This is a type of natural phenomena which falls under something called emergent structures through self-organization. Other self-organizing emergent structures are strongly comparable to this process. For instance, the development of hurricanes. Emergent structures are basically where randomness can give rise to complex and deeply attractive orderly structures. We see self-organizing take place in space with orbital planes in planetary systems, solar systems, and even in galaxies. As a side note, we also see it in star and planet formation, and to a large extent, the Big Bang. Given all this evidence, we have to assume that similar processes formed other star systems, and we have just about been able to observe massive planets orbiting other stars along similar planes too. So there we have it, why all planets are on the same orbital plane.